Because of the pandemic, many people are working and studying from home. Being able to have a comfortable study and work environment is very important for one's productivity. Having a room environment that does not have comfortable temperature and humidity range can worsen existing health conditions or increase susceptibility to health conditions. Research has shown that low humidity during the winter is a key factor in transmission of influenza. With people spending more time at home, humidity and temperature are important factors that affect one's comfort, health, and productivity. The MiHome is a portable smart home monitor that monitors the temperature and humidity of a room. This is accomplished using a DHT22 temperature and humidity sensor that collects temperature and humidity information about the room and displays this information digitally on an LCD monitor. In addition to displaying temperature and humidity data, our monitor outputs messages indicating whether the temperature and humidity are in normal range or out of range. According to our research, the ideal temperature and humidity range for rooms to be between 18 and 25 degrees Celsius, which is what we programmed our monitor to detect as normal temperature range. Studies also suggest that ideal home humidity levels should fall between 30 to 50%, but should never exceed 60%. Therefore, we program our monitor to detect 30 to 60% as our normal range. This feature is added so that users can make the necessary adjustments to a room's temperature and humidity level to return to a comfortable room environment. For portability, the MiHome is powered with a 9-volt AC adapter. Additionally, there is a casing used to hide the wiring to make it a bit nicer and presentable. How it works is our monitor authorizes a DHT22 temperature and humidity sensor that reads a room's temperature and humidity. The DHT22 is composed of two main components, a humidity sensing component and a temperature sensing component. The humidity sensing component composes a moisture holding substance sandwiched between two electrodes. As humidity changes, the resistance between the electrodes changes. High humidity decreases the resistance between the electrodes, while the low humidity increases the resistance between the electrodes. The second component is an NTC temperature sensor, or thermistor, which measures temperature. It is a resistor that changes its resistance based on temperature. Thermistors are designed so that the resistance decreases with increase in temperature. The change in resistance from these two components is what the Arduino reads and records as the raw temperature and humidity data. Here's a comparison chart of the DHT11 versus DHT22 sensors. While the DHT11 was more affordable, we chose the DHT22 because we wanted better accuracy of our temperature and humidity data. The DHT22 has a temperature accuracy of about 0.5 degrees Celsius and a humidity accuracy of about 2 to 5%. It also has a larger temperature and humidity reading range than the DHT11.
Okay, this is a introduction to the MiHome smart home monitor. As you can see, the Arduino as well as the breadboard have been enclosed in this cardboard casing just to be able to hide the circuit wiring. And we've also added a feature that the hole would be a bit larger to accommodate potential additional sensors in case we want to improve on the project in the future. The bottom flap is also removable, so in case we need to make any changes or corrections to the wiring, we're able to do so. This just lifts up and it opens up to be able to have the wiring visible and the microcontroller visible as well. And on the side, we have the power connections. So we currently have just a large hole fitted for either a USB, a 9-volt power adapter, or there's enough room within the enclosure to accommodate a 9-volt battery if we wish to do so. So this is an introductory video to the MiHome smart home monitor. We will be featuring 3 different scenarios, putting the smart home monitor into practice. Okay, so so this is a product demonstration of the MiHome Smart Home Monitor. We've included a casing that just hides the wiring of the circuit, breadboard, and microcontroller connection. It's been running for maybe about 1 minute, and current conditions would be roughly 20 degrees Celsius right now. Temperature reading is about 19 degrees, so just about 1 degree off. And current environment would be high humidity at the moment. But so far, this is a testing the condition under normal temperature, high humidity, and the ideal temperature range would fall between 18 to 25 degrees Celsius, which is what we programmed the normal temperature range to be. Okay, so the second condition that we demonstrate in the project would be we decided to leave the monitor in the freezer, and currently it does detect low temperature as expected. We did leave it for about 3 minutes. And another effect that we saw that was interesting is that the humidity also did drop to normal range. So this is a second testing condition in a colder environment, and I guess at a more normal humidity. The current normal humidity range that we've programmed would be between 30% and 60%. Okay, so another extra condition we decided to test was just kind of looking at the humidity after in outdoor conditions. So not exactly related to the room temperature, but just kind of interesting because the environment I'm currently in, it recently just rained, and it's also a higher humidity environment. So looking at the sensor data, the humidity is about 99.90%, which is, it did rain pretty recently, so it's not, off base, the data reading. So just kind of an extra condition to test out humidity data.
We learned many important things during our project. Being realistic was important to our project time management. We had many ideas, but figuring out a project that was attainable based on our skill level and available schedule was important so that the project was not too difficult and time-consuming to troubleshoot. Troubleshooting can happen at any stage of the project. One thing we found was that there were times when something would work at first, but something else happened unexpectedly. For example, we found that the LCD outputted strange characters even though the code did not change. This happened due to the lost connection between the wires and the breadboard, which was resolved, but it showed how important it is to be ready for potential troubleshooting at any stage of a project. How to research our troubleshooting. Related to our second point, based on our limited experience, it was important to learn how to research our problems. Using resources such as Google, YouTube, and electronics forums was important in understanding what the problem was and how to fix it. Sometimes, if the problem was not easily found on the internet, it might take some experimentation to solve a problem or a combination of the two. Simple is better. Because of the pandemic, some team members were not co-located, making team collaboration and resource allocation a bit more difficult. Being able to keep the project parts and components simple was important in order to better understand and explain how our project works, and to not overburden team members who might not have equal access to electronics components. The MiHome is a tool users can use to help monitor their room temperature and humidity in order to make any necessary changes to attain a comfortable home environment. Through the process, our group has learned how sensors and LCD work, and created the MiHome as a useful tool and application of our electronics understanding. We would like to thank our Langara College instructor, Cesar Lopez Castellanos, and teaching assistant, Henry Lay, for their assistance in creating our project.